Hi, this is Bill, the Techno Gypsy, coming to you from the Technog Command Post. In this video, I'm going to talk about powering your rig using a battery, the problems you may run into, and how to solve them. These concepts apply to both operating standalone, in the field, or in mobile applications such as in a vehicle. Have you ever wondered why your field rig works without a problem in SSB voice and CW mode, and then find you have to reduce output power to a very low level when switching to digital modes? In this video, I'm going to talk about this small device that I use to improve the performance of my radios when operating in digital modes on a battery. First, we have to understand why the problem occurs. This ties into the waveform of the transmitted signal and the instantaneous power requirements of the transmitter. Let's take a look at a simple sine wave that is modulated using amplitude and frequency modulation. The upper waveform is the information signal. In this animation, it is a simple sine wave. The middle waveform shows the information signal being amplitude modulated, or just AM. AM, in its most basic form, is simply the process of mixing or heterodyning an information signal with a carrier wave to produce a signal that has two sideband components in the frequency domain. This process is called double sideband modulation and results in the information signal being shifted up from the baseband to a carrier frequency. When this simulation is run, it generates a corresponding output on the spectrum analyzer window. The AM modulation process results in two sinusoidal terms, one below the carrier and the other above the carrier. In amateur radio, we refer to these components as the lower sideband and the upper sideband. The information signal is usually just the analog voice signal from your microphone. Looking back at the original graphic, the bottom waveform shows the information signal being frequency modulated, or FM. FM, in its most basic form, is a signal produced by modulating the frequency of a carrier with an information signal. The carrier is modulated in such a way that causes its frequency to fluctuate as the amplitude of the information signal changes. All of the digital modulation modes are derived from these two basic modulation schemes. Digital modes can utilize amplitude shift keying, frequency shift keying, or phase shift keying. Modulation modes such as quadritude amplitude modulation utilizes a combination of ASK and PSK modulation, thus the reason for using a constellation diagram to monitor a QAM signal. Digital modulation modes on HF utilize these basic forms of modulation to send data across the RF link. Unlike pure AM, the amplitude of the modulated carrier signal remains constant, and this is where the instantaneous power requirements of the transmitter come into play. A AM signal is not a continuous signal. Let's take a look at a voice signal in the time domain. When you speak into the radio microphone, the power supply needs of the transmitter ramp up over time following the audio waveform of your voice. You can see that the signal has lots of lows and highs and is not uniform. These transitions translate into the amount of power fed to your transmitter RF output amplifier. This non-uniform waveform allows the battery to ramp up the delivered power to meet the needs of the radio. In contrast, a FM modulated information signal, such as those produced when operating in digital modes, requires continuous power over the transmission time. The instantaneous power requirements of the transmitter may not be delivered by a battery which worked fine in SSB voice or CW mode. By now your eyes have probably glazed over with all of this technical information related to amplitude and frequency modulation. You're probably asking yourself, what does all of this have to do with powering your transceiver from a battery? Well, let's look back at the input power requirements for a transceiver. This graphic shows what can happen to the voltage of a battery when it tries to supply the instantaneous power demands of a transmitter starting a digital mode transmission. Remember, digital modes are basically FM signals. The nominal 13.8 volt power required to operate a transceiver may actually dip and go out of tolerance during the start of a digital mode transmission. Any power fluctuations that go outside this boundary will cause the transceiver to momentarily shut down the RF output power amplifier. This in turn corrupts the start of the message being transmitted and results in transmission errors. Now that we know the why, let's talk about how we can solve this problem without having to drop the output power of the transmitter in the dirt. This is where this little circuit board comes into play. It is nothing more than 30,000 microfarads of capacitance with a blocking diode and a fuse. The blocking diode isolates the capacitors from the battery so as not to backfeed the battery. Let's take a look at the schematic. This is a parts list for the board. The total cost to build this board is around $30. I 3D printed a case to hold the board. It is printed in two pieces that easily snaps together. I use this little board between my battery and the transceiver in all of my mobile environments and when operating in the field. The extra boost provided by the capacitor bank helps to meet the instantaneous power needs of the attached transceiver. I hope you found this video informative and useful for operating your rig using a battery. The schematic and parts list can be found on the Technog site at the URL shown below. This is Bill the Techno Gypsy saying God bless and 7-3.